Hey math kids, today we're going to talk about differential equations, and a differential equation is an equation involving a derivative of a function. And so if we have y equals e to the x squared, like that, they want us to show that that's a solution to this. So this is just the derivative. So if we take the derivative of this, we're going to get e to the x squared. So this would be dy dx. And then we have to times it by the derivative of the inside. And then if we just reorder that, we see that dy dx is equal to 2x times y. And so it meets the criteria, so we proved that. Now on this next one, they give us a derivative function or just a differential equation, and they want us to show that this is a solution. So what we're going to do is take the derivative of this, so that becomes dy dx. Now if we take the derivative of this, it's going to be c e to the 3x, and then we want to times by the derivative of the inside. This negative 1 will just go to 0. Now we're going to plug in the stuff we know over here. So we get c, or 3c, if I bring the 3 over here, e to the 3x minus 3 times y, which is c e to the 3x minus 1 equals 3. Alright, distribute the negative 3. This is the same as this, just negative, so they cancel. We end up with 3 equals 3. So that means that we have all real solutions for all values of c. Now they want us to plug in c equals 0, plus or minus 1, plus or minus 2, and plus or minus 3. I show that on a graph. If we plug in, so we're just looking here, if we plug in a 0 for c, this all goes away, and we just get a horizontal line at negative 1. Alright, if we plug in a positive 1, we'll just get e to the 3x minus 1, and so that's just going to be something that looks like this. So normally exponential functions cross at positive 1, but this negative 1 will shift it down. Now if we just make this negative 1, it's just going to flip everything upside down across that. And then if we plug in a 2, we're going to have the same, like this will be the asymptote for it, but it's just going to climb a little bit faster. So it's just going to go like that. And then if we plug in a 3 and a negative 3, we'll get something like that. Once again, you can look in your book to see a better drawing of that graph, but we're going to move on to part C. So find the particular solution which passes through 0, 2, and we'll just take this thing in the box, plug in a 0 for x and a 2 for y. So 2 equals c e to the 3 times 0 minus 1. This just all goes to 0. E to the 0 just goes to 1. So we just have c minus 1 equals 2. Add 1 to both sides, and we get c equals 3. And so the particular solution is when we plug in 3 for c. And so we'll just plug it in right here. Y equals 3e to the 3x minus 1. Okay, and part D, find the equation of the tangent to the particular solution. Alright, so what we're going to do, we're going to, let's see, we need this, and and we need this. So let's get some room. Alright. I'm just going to rewrite this. Okay, so I'm going to add this over here and write dy dx, or the derivative, is equal to 3y plus 3. And then if we plug in the particular solution, which was 0, 2, we're going to get dy dx is equal to 3 times 2 plus 3. And so the slope is going to be 9. Okay. And so if we do y minus y1 equals m, x minus x1, we can plug in the solution, which is going to be y minus 2, the slope 9, x minus 0. If we simplify that, we get just 9x, and we could add the 2 over there, and so y is equal to 9x plus 2. If you need additional help, please come to Math Lab. Until then, calculator.